Hello everyone and welcome back to this Learning Python for Beginners tutorial series. So let's continue with our snake game project. And so we had created the head, we had created the food, and we managed to take care of the collisions. So now let's go ahead and try and work with a tail. Let's try and create a tail. So let's save this new script as tail.py right there, and as usual, let's import pygame. That's it. So let's create the class and call it tail with capital T. Let's define our init function right there. Let's add a self, a position X, a position Y, a width, and a height. So the tail is pretty similar to the head, so this is why I'm going a little bit quickly over these, because we've already seen these before. And let's just create position Y, set it equal to position Y, self.position dot width equal to width, and self dot height equal to the height. Let's also create the same movement variable that we had before. Let's also define a draw function, self, and we need a display right there. And let's say pygame dot draw dot rect, and then here we first need to input the display, the color, and the coordinates slash dimensions. Right, so for this let's create a self.r for RGB, right? Self.r, self.g for green, R is red, and self.b. Alright, so RGB. Let's import random, our random library that we used before, and let's do random.rand int, so from 0 to 255, and same thing for the green and the blue. So here all we have to do is R, G, B, and add a self dot. So self.r, self.g, and self.b. So that's just gonna be the colors for which we print our tail, so that we can have a big diversity. Let's also input the coordinates, which are gonna be self.position X, self.position Y, 16 and 16. So now we're done with our draw function. We should also take care of the movement. Alright, so let's say we're moving this way. We're moving this way. All we need to do is take the position here and just simply, after we move this one, just simply change the position of this tail right here to the position of the head, and change the position of the second tail to the position of, let me change color right here, position of the second tail to the position of the tail before it. Alright, so all we're doing is shifting positions. Therefore we do not need a speed variable, because all we're doing is shifting positions. So if we want to define our moving function, all we need is the self, a position X, So let's call it px and a py, just to make sure that these two are different. All right. So a px and a py, and all we'll do is set self.position x equals px and self.position y equals py. So that's it for the tail. All right. Let's import our tail script, and here, instead of creating a tail object, let's create tails. Tails object is going to be equal to an empty list, because we want to keep track of as many tails as possible. Now here, each time we have a collision, what we should do is create a new tail. Alright, so let's say tails dot append to add an element to our list. So what we want to append is tail, so we're going to append an object. Alright, it's going to be a list of objects, tail dot tail, capital T, and here if we look at it, we define a position x, position y, width, and height. Let's say if tails equal to null, we can say if it's equal to an empty list, then tails.append tail.tail, the position x will simply going to be s head x, position y will be s head y, the width will be 16, the height 16. I noticed an issue. If we're going right, we can also change direction and go left, which we shouldn't be allowed to do, so we'll have to deal with this later on. Also, I just noticed something. Whenever it's generating the fruit, it's not generating at the same level of our snake head, which is something that I don't appreciate. So let's just fix that. Alright, so what we're gonna do is, here we're gonna multiply by 16, multiply by 16, and then here we're gonna divide this we're gonna change this to an 8. We're gonna change we're gonna change no, actually let's keep it 16. We're gonna divide by 16 each, and then we're gonna add 8 to both sides. Control C. Now let's just copy it here, this new formula. Let's copy it here. Let's just say for every tail in tails, let's just do tail dot draw and passing a display in there. Alright, this way we do not confuse with this variable, this tail variable that we created here in the for loop, because if we import it as tail, then the program is gonna confuse them. When we say import tail as t, it's gonna simply replace this class name by t. So whenever we had tail in reference of tail.py, we can simply replace it by t. Alright, so we can say t.tail for creating our object, where the tail has more than 2 fruits. Okay, so if we take a look at what's happening here, we're always appending, we're getting the position of the tail that is before us, and then we are creating a new tail at that position. So let's do the same thing for the else statement. Let's remove the pass right here, and let's do this. Okay, let's create a tx and ty variable and make it equal to tails alright, and then in brackets let's put -1. If you remember from our list tutorial, this will get the last tail available, and let's get the position of that tail. Okay, and then do the same thing. Let's take our tails list, append, so we can add an object. Let's create the object. We'll say t.tail, and as the x we're gonna pass in tx, the y is gonna be ty, the width and height are gonna be 16, and let's get rid of these movement parameters because they are pretty useless. So let's just get rid of them. We can now run the program. As you can see, let's try and eat more than 2 fruits, and hopefully they will all spawn. So we eat the first fruit and it did spawn. We eat the second one, and as you can see it spawned at the location, and the third one, and it seems to be working properly. They're all spawning at the correct position. So now let's try and handle some movement. So let's start by working with the very first tail. So let's say if the length of the tails list is greater than 0, meaning we have eaten at least 1 fruit and we have at least 1 tail. What we want to do is create an x and y variable for the tail and make it equal to the snake head's position, s head dot get position. Okay, and now what we're gonna do is take our first tail, tail 0, and move it to tx and ty. So all we're doing here is we're getting the position of the snake head, okay, and then we're moving the very first tail, we're moving it to the snake head's position, and after that we're moving the snake head. Okay, this way after the tail, the first tail takes the snake head's position, then the snake head will move. This way the snake will move properly. Now let's try it out. So it is there, but it is very pale, so we can barely see it. Let's restart the game so that you can notice properly. There you go. As you can see, the very first tail is following the head, but the third and the fourth one did not, because we didn't code that yet. Okay, so here let's go before that. Okay, because you have to understand that this movement dynamics is a little bit strange. When we're moving the snake, we go from the back to the snake all the way to the front. We start by moving the back, and then we go all the way to the head. So let's say we're at the last tail. The last tail will move at the position of the tail before it. The tail before it will move to the position of the tail before it, and so on and so forth. Alright, so when we reach the first tail, then that tail will move to the snake head's position, and the snake head's position will move according to our keyboard input. So this is why we have to go before this. Okay, so this is moving the first tail. Let's go before this. Let's create a reverse for loop. So let me explain. For I in range, this you already know how to do. So for I in range, and then we'll start at 1, and we'll go all the way to the length of our tails list. Okay. And there's 2 steps. There's getting the position of the tail before us and assigning it to the current tail. Okay. So let's create a tx and ty, which are the coordinates of the tail before us. So in this case, this is the first tail 0. So this is why we're getting the position of the head, because we're dealing with the first tail. In this case, we're dealing with tails in general. Okay. So to get the position of the tail before us, we'll have to say tails. We'll take the length of our tails list. Let's say we have 4 tails, so this returns 4 minus I. Okay, this way we have a decreasing function. So if you remember from your math class, we have y equals mx plus b. Alright, in this case m equals 1, so we just have x plus b. Now if you take the negative of x, this has a decreasing slope. And if we move x to the right and take b to the left, we have b minus x. Alright, which is the same format. So len of tails, so the length of our tails, is kind of like our b, and minus I is our x equivalent. So this is decreasing. Alright, when I increases, y decreases. So this decreases. So that's what we're doing here. But as I told you, we're looking for the tail that is before us. Okay, we have, for example, we're at tail 3. We're looking to get tail 2's position. So let's also shift by 1. So say minus 1. Alright, and now that we have this, we can say dot get position. So this is a function which we created here, get pos. Alright, we have to use it on the current tail that we're getting at. So we have to use this to get the x and y. And now what we have to do is simply say tails, and then for the index we're going to take the length of tails, simply say that minus I. Alright, and what we want to do is move it at tx comma ty. Now let's go ahead and run this. Let's try and move this out of the way like this. Let's eat the little fruit. So as you can see, we have an object that's added to our list, and as you can see, the movement is pretty smooth. Perfect. This is exactly how we wanted it. Alright, so we're moving from the back of the snake all the way to the front, giving this illusion. Now we still have an issue. Look, whenever I hit the wall, I respawn with the entire length of the snake. Another issue is that I can change direction like this. Alright, I can go up and then down, and down and up. Alright, so let's start with the respawning issue. If we go to our snakehead.py class, this is where we're handling our respawning whenever we're hitting the wall. So let's get rid of this. Alright, let's save it and move it to main.py. Let's move it right here before the movements. Okay, now since we're not inside snakehead.py, we cannot use we don't have access to self.positionx anymore. We have to use the snakehead object to access these variables. So let's create, for example, a sx comma sy is going to be equal to shead dot get position. Alright, we've done this a couple of times. So let's replace self.position x with sx, which is our new variable, and do the same thing here, sx, and replace self.position y with sy, and same thing here. And now to access the restart function, we'll simply use the snakehead object. So sHead.restart. Now, since we have moved this bit of code to our main.py script, we can also add tails.clear, which will get rid of all details which were stored inside our tails list. Alright? So by doing this, we can try and run the game. Oh yeah, we get an issue because SW is not defined in here. It's screen width and screen height instead. So let's say screen width and screen height. Let's run it. Yes, this is not spaced properly. This has to be moved back. Alright, so now it works. Let's go ahead and try and eat the little fruit so that our snake may grow. And you can even keep track of the objects right here, the list of objects. So whenever I eat the fruit, the object list will increase. Okay? Alright, so now I have 4. Let's hit the wall. And as you can see, we restart as a new snake. So the game restarts. So now this is working properly. The only issue remaining is the change of direction. We cannot change like this. This is not allowed in the game. So let's go here, where we're handling the movements, right there. So this is where we'll fix the issue. We're saying if the key pressed is the A or the left key, then we'll set the movement to left. We also want to check that we're not already moving to the right. Alright, so let's add a parentheses right here. So the first condition is that we're pressing left, and let's add another condition by saying and self.movement has to not be equal to right. Okay, so basically if we're pressing left and we're not moving right, then we're allowed to set the movement to be equal to left. Okay, let's do the same thing for the other conditions. Let's add parentheses to make the program understand that these two go together. Okay, so we're handling these two as one condition, this as a second condition, and if both happen to be true, then this will execute. So if the movement is not right, if this is true, and we're pressing a left key, then we're allowed to move left. Alright, let's apply the same logic here. So basically, if we're not moving left and we're pressing a right key, then we can go right. Here, if we're not moving down and we're pressing an up key, then we can go up. And if we're not moving up and we want to go down and we're pressing a down key, then we can do it. Alright, so now whenever I press an opposite direction like this, it doesn't let me do it. So the problem is now fixed. So the game is almost complete by now. The only thing that's left to do would be to add a score somewhere on top of the screen, and this is what we're gonna do in the next video. So stay tuned and have a good one. Also, I just realized that whenever the snake runs into itself, the game also have to restart. So this is also what we're gonna be working on for the next episode. So stay tuned for that too.